So, physics students, you might be asking yourself, how do I make up numbers for momentums that support or refute my hypothesis? Well, first of all, obviously your hypothesis either is going to say that the momentum of these marbles going just before the collision is equal to the momentum of the marbles just after the collision, or your hypothesis is going to say that the momentum going into the collision of both marbles is not the same as the momentum of the marbles leaving the collision. Either way, you're still going to have to make up two sets of data that support and refute your hypothesis. So let's talk about why I wrote a methods section and showed you what the experiment looked like. First of all, the tape measure track that the marbles are moving on is a total of 142 centimeters long. Okay? Now, second of all, the software I'm using to record time I'm gonna use it to find out how much this, say this is marble 1 and this is marble 2, right? I'm going to use it to find the distance marble 1 travels in 0.2 seconds, so the time there is already given, towards the collision, and the distance marble 2 travels, okay, in 0.2 seconds, also heading towards the collision. Now, I want to point out something important here, all right? Momentum is mass times velocity, all right? So this isn't actually a distance here, it's a displacement. And displacement is a vector that has direction. And the way we indicate direction in a linear collision is by choosing one side of the one direction to be negative and the other direction to be positive. All right, so I'm going to decide that's negative and that's positive, okay? And I'm going to keep that in mind. But before I even do that, all right, the distance these two things travel, the magnitude of their distances, of d1 plus d2 cannot be greater than 1.42 meters because that's the total length of the track. All right? So, I chose this side to be negative and this side to be positive. So once I choose my distances, okay, that means marble 2 has a negative displacement. It's moving this way in the negative direction. And marble 1 is going to have a positive displacement moving in this direction, from negative to positive. Okay, so that should give you, an idea about what these numbers should be. Then, of course, displacement divided by time is going to give you the two velocities. And we have the mass of the marble is 8.3 grams. And if you want a proper momentum number, you're going to have to convert this to kilograms. So that would be the same as 0.0083 kilograms. So you've got your D1, right? You've got your your time one. You got your D2. You got your T2. Then you've got your velocity 1 and your velocity 2. Okay? Now, one of these is going to be negative. All right? And then finally, you've got your momentum 1 and your momentum 2. And then finally, your total momentum. Now, if you fill in the formulas for these, and you're trying to make total momentum equal on one side as it is on the other one, with the distances moving away, right? It's going to be easier to do this whole first column and get your average of total momentums so that you can choose fake numbers that make them the same in one condition and different in the other at the end. All right. Now, finally, if you think about it, if you really, really think about it, right, you've got this, is the distance going to be the same each time if we're just using our hands to push them together? I would say no, right? The distance that this marble travels in 0.2 seconds headed towards the collision the first time I try it is going to be a little different from the distance traveled the second time. And I wouldn't expect them to be the same. So them being different isn't really an error. So error in this lab is going to involve the accuracy of the software, I use to collect the data. And I'm going to say this. I'm going to say that my software, its time accuracy is accurate to 0.05 seconds. Okay? Meaning it's not better than that. So how much of 0.2 seconds is 0.05 seconds? So this is plus or minus 0.05. Well, 0.05 divided by 0.2 tells us how much error, or how different these measurements could be from each other. So there is a plus or minus 25% error. All right, so what are some other places error comes into play? Well, when you're looking at a tape measure, if you line up your head so that the number you're looking at's between both of your eyes, you can use it accurately. However, I want to remind you that the tripod with the camera is set up over here, and it is looking at the tape measure at an angle. And the marbles could collide over here, which means when I freeze the frame with the software at the marble collision, I'm trying to read the measurement on the tape measure at an angle where my perspective is going to interfere with the precision of each measurement. Okay, this is a little bit of discussion of error here. Remember that if displacement 1 is positive, displacement 2 is negative, and then as they head away from each other, displacement of marble 2 is going to become positive, so d prime 2 becomes positive, and d prime 1 becomes negative on the other side of the table. All right, y'all. let's sum it all up. Number one, the magnitude of these distances must be less than 1.42 meters because that is the length of the track. Okay? Second important point. If distance 1 is positive heading into the collision, it's going to have a positive velocity. Okay? But that means d1 prime on the table further over is going to have to be negative because it's going to be headed this direction after the collision. If d1 is positive going in, then d2 is moving in a negative direction before the collision. So this displacement has to be negative, and then d2 prime is going to have a positive number for its displacement. Finally, in the error analysis, okay, you're going to use the accuracy of the software that I stated for your calculation of error, and it would be an error of time, okay? And you're going to discuss the perspective of the camera setup. That is important. You might come up with some other errors if you look at that footage of the marbles rolling along the track. These are not the only two things going on. I would like it if you try to think of a third or fourth error with the way the experiment is set up.